Dear students, I am Dr. Divya Haridas and I am going to present a chapter on sound and communication. In our daily life, we come across many sounds, sound of birds, animals, vehicles, or talking with each other. There are so many types of, so many tones and so many levels of loudness. After completing this lesson, the learner will be able to understand the following objectives. The objectives are to describe the characteristics and nature of the wave, to distinguish different types of waves, the mechanical or the sound wave and the electromagnetic waves, to explain the use of different kinds of waves which are used in communication devices such as sonar and radar, characteristics and the nature of wave. Sound is a result of vibration. The vibration is produced by a source which travels in the medium as a wave and is ultimately sensed through eardrum. Let's try to understand it better by an activity. We can do a simple experiment to show the association between vibration and sound. Take a rubber band of sufficient length, stretch this rubber band. I have wound it over a tumbler. Now, if you pluck the string, you will hear some sound. You would notice that the sound vanishes if I hold the string after plucking. If you look carefully, you can realize that the sound comes only as long as the string vibrates. If you strike a steel tumbler with a spoon, hear the sound and then hold the tumbler with firm hands, the vibration will cease and so will the sound. We observe that every time something is vibrating, these vibrations travel through air, the medium, and reaches our ear, which senses the sound by receiving the vibrations. So, sound has an association with vibrations. These vibrations are transmitted in a medium, mechanically, and that is how sound travels. It travels like a wave. A medium is a must for mechanical waves like sound to travel. You will be surprised to learn that without some aid, we can't converse on moon as we do here because there is no air on the moon and sound needs a medium to travel. A wave involves a periodic motion, movement that repeats itself. It also transports energy. Let's understand waves better. What happens if you throw a stone in a pool of water? You will see a disturbance of circular shape moving from the point of fall of the stone outwards. The disturbance is made up of a raised ring in water which seems to travel outwards. Soon, there is another similar circular feature originating at the same center and moving outward. This goes on for quite some time. You can see this type of wave on the screen. Even though there appears to be a movement of material, actually it is only the position of the disturbance that is changing. This is a wave and it is made up of a raised part that is crust and the lower part which is called trough. So, a crust and trough are essentially components of a wave. A wave transfers energy from one point to the other without the medium particles moving from one point to the other. Thus, wave is clearly different from particle. Let us discuss how we can represent a wave. We need to describe a friend by name, height, color, gender, etc. for identifying. Similarly, we have to specify some qualities that we shall call parameters for wave description. A wave is represented in terms of wavelength, amplitude, frequency and time period. Wavelength. The distance between adjacent troughs or crust measured in unit of length such as meter and expressed by the symbol lambda. For longitudinal wave, it will be distance between two successive rarefaction or compressions. Time period. This defines the time it takes for one complete wave to pass a given point and is measured in seconds. Frequency. The number of complete waves that pass a point in 1 second, which is measured in hertz. Speed or velocity. Wave speed is defined as a distance travelled by a wave disturbance in 1 second and is measured in meter per second. Speed is a scalar quantity while velocity is a vector quantity. Time period is inversely related to frequency. This means if the frequency is high, the time period will be low. This is understandable because frequency is number of times a wave completes a set of up and down movements in 1 second. If these occur very frequently, it has to be done in a very short time. Mathematically, one may say that time period t is equal to 1 upon f, where f is the frequency. I just said that the wavelength is equal to the distance between two successive crust or trough. So, in 1 second this distance is covered a number of times given by frequency. So, velocity can be defined as the product of frequency and wavelength. The waves that produces a sense of sound for living beings are called sound waves or audible waves. Only those waves that have frequencies lying in the range of 16 Hz to 20,000 Hz are audible to human beings. Movement of sound in air. Sound waves travel in fluids and solids as longitudinal waves. A longitudinal wave is a wave in which vibration or the displacement takes place in the direction of the propagation of wave. Sound waves due to difference in pressure. If a sound is produced in air, it compresses the adjacent molecules. Due to the compression, the air pressure increases. This causes these compressed molecules to move in the direction of pressure, that is, the direction of the wave. But displacement of the molecule causes fall in pressure in the place where they have left. So, if the wave is continuing, then another rush of molecule comes in, fills the empty or the rarefied space. This process is repeated and the disturbance propagate. Thus, a chain of compressions and rarefaction is generated due to sound. They travel and transport energy. If there is no medium, then produced sound will not be able to push any medium molecules and sound will not come. Let us discuss about different types of waves. Waves can be mechanical or electromagnetic. Mechanical wave is a term used for those waves that require a medium for traveling. An electromagnetic wave results from acceleration of charge. It does not require a medium to travel. It can travel through vacuum, as in the case of light waves which can travel from stars through empty space to reach us. The sound wave is a mechanical wave, but light waves, infrared waves, X-rays, microwaves, radio waves, etc., these are electromagnetic waves. Gamma rays are also electromagnetic waves and result from radioactive decay of the nuclei of atoms. Compared to sound waves, the electromagnetic waves are more energetic. They travel at the velocity of light, which is about 3 lakh km per second in vacuum. In comparison, the sound waves travels very slowly. In air, it travels at 330 meter per second. The velocity of sound changes with the media as shown in the screen. You can see that whenever the sound moves in a steel medium, it moves with a velocity of 5200 meter per second, whereas in case of glass, it moves with 4540 meter per second. Students, you can observe that sound waves moves faster in solids than in gases or liquids. Such difference in the velocities of light and sound means if there is an event in the sky which produces light and sound both, we shall see the light almost instantaneously. When there is a lightning in the sky, we see the light before we hear the sound. Mechanical wave can be either transverse or longitudinal, while the electromagnetic waves is only transverse. The transverse waves is one in which the motion of the wave and of the particle are perpendicular to each other. In a longitudinal wave, the motion are in the same direction. Sound wave can be of two types, both transverse as well as longitudinal. We can try to visualize transverse wave by tying one end of a rope to a hook in a vertical wall and hold the other end such that the rope remains loose. If we quickly give up and down jerk to the rope at our end, we see the wave traveling between our hands and the peg, while the points in the rope move perpendicular to the rope and the wave. This is transverse wave, as the particle of the medium move perpendicular to the direction of wave movement. Similarly, when we throw a stone in a stationary water in a pond, we see that on water surface the wave moves from the center to the shore. If we see a duck or a small paper boat there, it oscillates up and down with water without shifting the position horizontally. That makes it a transverse wave. You can see the electromagnetic spectrum on the screen. One can clearly see that the frequency of gamma rays being the highest and the radio waves have the lowest frequency. Since the wavelength is inversely proportional to the frequency, so the wavelength of radio waves is the highest, which is almost greater than 10 to the power 9 angstroms, and the wavelength of gamma rays is very low, which is even less than 0.1 angstrom. In a longitudinal wave, the displacement of the particles and the propagation of wave are in the same direction. For instance, if we blow a horn, speak or quickly move an object in air, we are pushing the air molecules. These molecules in turn push the adjacent molecules, which impart their energy to the next one. After losing energy in the interaction, the molecule is back to the original mean position. So this results in formation of compressions and rarefactions. So it is a compression or rarefaction which is travelling and not the molecule. While transverse wave form only in fluids such as air or liquid, the longitudinal wave can form in all the three media, that is solid, liquid and gas. Now let us discuss about the nature of sound, the quality of the sound and how to measure sound. Sound level is measured in units of decibel. Here deci means 1/10 and bell is the level of sound. The term bell is after the name of inventor of telephone, Alexander Graham Bell. Actually, it's a unit which compares two levels of power of two sources. Two power levels P1 and P2 are known to differ by n decibel only if n is equal to 10 log base 10 into P2 by P1, where P2 is the sound which is measured while P1 is a reference. Normally, the reference is a sound which is just audible. For average human ears, the whisper is about 30 decibel, the normal conversation is about 65 decibels, while a jet plane taking off makes a noise of around 150 decibels. Beyond 85 decibel, sound is damaging and can lead to temporary loss of hearing. Prolonged exposure to noise can cause permanent hearing loss. Noise raises the blood pressure and causes anxiety and tension. So what is a characteristic of sound? Sound has three characteristics. 1. Loudness. How high or low is the level of sound concerned with the amplitude? Second is the pitch. How thick or heavy or thin or shrill sound concerning frequency. Third is the quality, which is the uniqueness of sound concerning waveforms. Different sources sound different. It is the quality which makes us able to identify different sound sources. We should not confuse between loudness and pitch. Sound from a metallic tumbler on hitting with a metallic spoon is higher in pitch than sound from a pitcher when hit with a wooden stick. The voice of females is generally higher in frequency than male voice. However, we should also know that voice is not just one frequency. It is a mix of many frequencies, some of which are multiples, which are called harmonics, of the same frequency, which is a fundamental note for that person. Now that we know the relationship between wavelength and frequency, we can appreciate why a flute produces a higher pitch, that is smaller wavelength and larger frequency, when all the holes are open. When all the holes are closed, it produces the largest wavelength, and by blowing harder, we can produce louder notes. Students, you can do an activity at home. Take a hollow, preferably metallic box. You may use a plyboard or a cardboard box. Take 3 pieces of metallic strings, which may be available from any musical instrument. Fix the nail or bolt as 3 sets of 2 each on the box as shown in the screen. The distance between the nails in the set should be kept different. Say nails are placed by 10 centimeter, 20 centimeter and 30 centimeter respectively in 3 sets. Now stretch the metallic string between each pair of nails. If you pluck the string, you can hear some sound. For each length of sound, the sound will be different. The shorter string will produce higher frequency. The longer string will allow a longer wavelength to be set up and hence have the shorter frequency. This is also the principle on which sitar and other string instruments work. The frequency also depends on the tension in the string which is vibrating. Now let us discuss about sound, music and musical instruments. Music. Music is a set of sound that is pleasing to hear and is not random. It refers to the quality of sound as well as the tune. Noise is random and irritates, while music has periodicity, whether in beats or in rhythm. In India, we have many musical instruments such as flute, bansuri, sitar, sarod, tabla, drum, ghadam and even more. Western instruments like guitar, piano and harmonium are quite popular. Some are string instruments where sound is produced by plucking a string and setting it to vibrate, such as tanpura, sitar and iktara. Some like tabla and dholak are percussion instruments where the membrane is made to vibrate by striking with hand or a stick. Then we also have flute and trumpet. Here we blow air into the pipe to produce sound. Now let us discuss uses of different kinds of waves in communication devices such as sonar and radar. Sonar stands for sound, navigation and ranging. This works on the principle of echo of transmitted sound waves from objects. For instance, if you hit a wall in front with a tennis ball, the ball will bounce back to you. But if the wall is removed, the ball will not come back to you. Thus, even with eyes closed, you have a way of knowing whether there is an object or a rebounding surface in front or not. Sonar works in the same way. The advantage of using sonar waves over electromagnetic waves is that electromagnetic waves loses energy fast in the ocean water because water can conduct electricity. In contrast, sonar waves can travel farther in water. There can be of two types of sonar setups. One is passive and another is active. In passive sonar, one detects sound waves that are present around. Leonardo da Vinci did it as early as 1490 AD. He dipped a pipe in water and placed his ear next to the end, which was out of water. He used this to detect the waves generated by ships. Today, the techniques are far more sophisticated. Sonar became a topic of very serious studies during the World War II as detection of movements of ships and submarines assumed significance. Active sonar is very important. It has two major components. First, a transmitter, which consists of a signal generator, power amplifier and a transducer. Second, a detector, which may be a single detector or an array of several detectors. One has to ensure that the signal is sent as a narrow beam. If not, then the reflections will be coming from many directions and will be confusing. Theoretically, the distance travelled by the waves is twice the distance between the transmitter detector and the target to be detected. So, if velocity of sound in water is v, then the distance of the object is given by d is equal to half into v into t, where t is the time lapse between transmission and detection of sonic signal. Radar. Radar is an acronym of radio detection and ranging. Radar is a radio wave equivalent of sonar. In radar, a radio wave does the same job as sound waves in sonar. Radar is useful in many ways, like observation of atmospheric objects and phenomenon like clouds, cyclones, raindrops, etc. and prediction of weather. In air traffic control, in ship navigation, also in military uses for early warnings. The basic element of a radar system are: first, a pulse source and a transmitter with an aerial which would emit radio waves. Second, an object which would reflect the radio wave. Third, the receiver, which may be an antenna and a display system like cathode ray tube. So, the transmitter in a radar system generates and sends a radio wave. The radio wave goes in all directions. If there is any object, the wave is reflected by it, then there has to be a receiver to detect the reflected wave. The radio waves are electromagnetic radiations and travel at the velocity of light. It's obvious that the time gap between the outgoing radio waves and the arrival of the reflected wave is very small. So, what is done is that as soon as the radio wave is emitted, the transmitter is switched off and the receiver is switched on. Thus, the reflected wave is not masked by the emitted wave, and even a weak reflected wave is not missed by the receiver. If after certain gap there is no reflection received, so we can presume that there is no object within certain distance that we can switch off the receiver and switch on the transmitter. Radar is useful in air traffic control as it can see in the dark. It can monitor movement of clouds. It can detect presence of distant ships and big animals like whales in sea. It can also be used to estimate the speed of the object approaching or moving away from us. It is used by weather scientists to track storms, tornadoes and hurricanes. It is used in tracking satellites and also in mapping Earth's surface. Let us summarize what we have learned in this chapter. Sound results from vibration and needs a medium to travel, be it gas like air, solid or liquid. It is faster in solids than in liquids and is slowest in the gases. Electromagnetic radiations also are waves, but they can travel through vacuum. Waves, sound or electromagnetic all involves periodic movement that repeat itself. A wave is described in terms of wavelength, frequency and amplitude. Velocity is equal to the product of wavelength and frequency. Noise is random while music is periodic. Music is pleasing to hear, but it is also subjective. Sustained exposure to noise and even music at high decibel harms. The functioning of musical instruments like tabla, sitar, bansuri can be understood as vibrations in membranes, strings and organ pipes. Sound navigation and ranging, that is sonar, and radio detection and ranging, that is radar, are two techniques which have many applications. They make use of sound and electromagnetic waves respectively. Sonar is more useful than radar in water, as electromagnetic waves lose energy fast in water. Thank you so much.